Okay, let's give you guys some more practice. So if you get yourself a graph plotter and plot this here, it will then give you this graph here. The question is, differentiate this. How do you differentiate this? So press pause and have a go. Okay, so to do this here, rewrite this as as this thing times this thing to the power of -1, and then we can use the product rule rather than using the quotient rule. Okay, so now differentiate this. It will then give you this. Okay, yeah, so remember, this thing gets multiplied with this, and then you've got to times dy by dx. Well, and then you using the product rule, it means that you differentiate this, keeping this the same. So that when you differentiate this, it gives you this, and then keeping this the same gives you this. And then the next step is to plus, so plus, and then you keep this the same, and then differentiate this. So you keep this the same, which is this here, and then you differentiate the whole thing here, which will then give you this. Okay, and then next step, yeah, and then it's just a matter of tidying up. So you yeah, so it's just a matter of tidying up, blah 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 here, blah blah blah, and then so dy by dx equals this here. Okay, but a better way of doing this is to do this. Originally, the question was this: differentiate this. But rather than rewriting this as this here, 7x squared minus 4, rather than writing this as this here, plus 7 to the power -1. Rather than rewriting this as this here, we could do this. Multiply both sides by this bubble here. So that will then give you this. Okay. Now use the product rule on this and this. You see, this is easier to do rather than having blah 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 to the power -1 here. This is harder to do. There's no to the power -1 over here. So this side is easier. Okay, and how do you know that you can how do you know that you can multiply both sides by this when it comes to implicit equations? Well, if you get a graph plotter and plot this, and then get a graph plotter and plot this, it should be the same graph. So that gives you an indication, or that you're allowed to do that. It gives you an indication. Okay, so well, anyway, so times both sides by this, it will then yeah. So use the product rule on this. Okay, so that will then blah 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 here. That so here you visualize it as this here. So you differentiate this, that will give you this, keeping this the same. That's this the same, and then plus, and then keep this the same, which is this, and then differentiate this. That will then give you the 5. Okay, and this here is quite straightforward. Okay, so it's blah 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 here, and then you would blah blah blah, and then dy by dx equals this. So so this method gives us dy by dx equals this thing here. The previous method gave us dy by dx. So this, oops, sorry. So this method here gives us this dy by dx as this. The previous method gave us dy by dx equals this. In fact, these two are exactly the same. Okay, they're exactly the same. And how do you know they're exactly the same? So this is where you have to investigate. Originally, we started out with our graph looking like this. Okay, so when you plot the graph, it looks like this, and then select one point on this line. Select any point. Choose an easy point. I chose this and this here. And the way I knew that y equals this is by looking at the graph plotter. So that's a downside of implicit differentiation. You need to know the precise point on this line. Sometimes you don't know what y is, so that's a downside. Well, anyway, looking at the graph plotter, choose a point on here that's easy. You can choose these ones. They're nice and easy. So choose a point that's easy. Choose this, and then try and draw a tangent line that just touches these two by first using this dy by dx, and then try to draw a tangent line using this dy by dx here, and hopefully the two will be the same. Okay, so our aim is to select our aims well, we want to know if this is truly equal to this. And the way we do that is we're going to try and draw a tangent line using this one, and on a separate occasion using this one here at this point here. So at this point here. So hopefully our two lines will be the same. Okay, so hang on. So the first method, dy by dx, it was given to us by this. Okay, now at that point, the gradient dy by dx equals this thing here. Okay, let's just round it off to this bit here. Okay, and then so we know the gradient equals this because dy by dx, that is well, we know the gradient is this using our first method. Okay, using our first method here. Okay, using the first method, dy by dx equals this thing here. So an equation for the tangent line, hang on. So an equation for a straight line is y equals mx plus c, going through this point. Well, we know the gradient. We just worked it out as this. So we put that into the m. We know that this is the x value, so we can put it into here. This is the y, so put it into here. Now we can work out c. Okay, so blah blah blah, c equals this. Now we've got our equation of our tangent line. Y equals this. Now if you graph this on your plotter, it should look something like this. And looking at this, roughly we can see that it's an indication that it looks quite true, because it just touches the 2 here. Now using our second method, for the other method, remember the other method was this, using the same process, going through this point here, dy by dx is blah blah blah, the gradient will be this. Okay, and going through the same thing here, the tangent line blah blah, c equals the same thing here, and then if you plot this line here, it will, well, it's in effect the exact same tangent line. So yeah, so earlier we had two methods. Hang on. Well, anyway, I'm going to start again here and just scroll through it so you can see. I asked you to differentiate this. Okay, and then you did, yeah, and then rewrite this as a product rule, blah 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 here, and then blah blah. Well, I'm just scrolling through this so that you can press pause and see for yourself. Okay, hang on, I'm just scrolling through. So yeah, okay, blah blah blah. Hang on, still scrolling through. It's just so that you can scan through the whole thing in one go. Okay, well anyway, blah blah blah, blah blah, that's it. Okay?